Right, good afternoon. Question of the day is, what is your favorite board game? So what is your favorite board game? So we got, give everybody a couple minutes to jump in and then we'll get rolling here. We're going to do something cool this week. We're going to actually do our Zoom check-in with the Astronomy Club this week. Trying to firm up a time. Mr. Zwartz and I do Astronomy Club together. We were in the process before this whole COVID thing happened. We were in the process with the Astronomy Club of putting together model rockets that we were going to launch. Probably at the athletic fields at school, but obviously that got cut short. We didn't even get to finish building them. So I have some model rocket kits. Actually, hold on. I actually have a model rocket kit that I just happen to have at home. Gotta always have these on hand, right? And what I'm going to do Friday morning, I believe, I'm trying to firm up a time, like I said, with Mr. Zwartz and the rest of the Astronomy Club, is I'm going to go to one of the local parks and we are going to launch a model rocket. So it'll be kind of exciting. You'll be able to watch it live. Hey, what's going on, Denzel? So, like I said, I'm just waiting to find out with Mr. Zwartz what time we're going to be doing that at. But it will be either Friday morning or Friday afternoon. Again, I know that most of you guys are sleeping during the day and are awake at night, so I don't think doing it early in the morning would be a good idea because most of you are probably going to be asleep. So I'm guessing it's probably going to be in the afternoon, maybe 1 o'clock, but I should know probably by tomorrow when we're going to do that. So it'll be a lot of fun. Hopefully I don't blow myself up. If I do, you get to watch it live. How exciting would that be? So, Denzel, what's your favorite board game? Favorite board game? I've probably been playing a lot of board games or video games or something lately. Probably should have played more board games with my family, but my kids are all playing Minecraft and Roblox and Fortnite, so we haven't really had an opportunity to play some board games. Do you really know how to play chess? I had Daniel, who's in my chemistry class. He is phenomenal at chess. He's on the chess team at school, and I played him, and he kicked my butt. So, are you good at chess or bad at chess? Because if you're bad at chess, we should play because I need to boost my self-esteem back up. You're cold at it. I'm guessing that means you're good. So, we'll wait about another minute, and then I will reveal my favorite board game of all time. Can you guess it? Can you guess what my favorite board game is? Don't say Monopoly. It's not Monopoly. Monopoly ruins families. I really think it does. All right. Oh, 103, so let's get rolling. My favorite board game of all time is Risk. Risk is a little complicated, but once you get the hang of it, it's actually pretty entertaining. There's some skill involved, but you're just rolling the dice and going against people. So, things can turn on you really quick if you have a really lucky hand. So, I don't know. I really enjoy it. But Risk is another game like Monopoly where it can turn violent and, it can ruin families. So, we should play Fortnite. I was thinking because sports have gotten canceled, we should totally get a bunch of people together and play Fortnite and live stream it. Hey, Sarah, we were just talking about your brother, Daniel. Denzel here is apparently awesome at chess, and he and Daniel should play because I'm not very good. I don't think I even took one of Daniel's pieces when I played chess. He totally kicked my butt. So hopefully everybody had a great weekend. The sun came out and it was warm yesterday. I power washed our entire patio over the weekend. We actually own a power washer. I bought it last summer because it's like $60 to rent one of those things. So we have a lot of concrete on our patio, and I'm like, well, after a couple years, it would pay for itself if I just bought one. So I bought one. And I'm power washing everything: patio, sidewalk, driveway, steps. I'm power wash my grill. It's gonna be great. I feel like a lot of life's problems you can solve with a power washer. I could probably solve COVID with the power washer. Just power wash everybody with it. It probably doesn't get rid of COVID though. Anyway, the other thing that I've been working on, I've been playing Fallout. Like totally in love with that game. So let me show you what I've been doing. Look at this. So this is settlement that I'm working on, and I've gotten really good at building things. So as you can see, there's a lot going on here. All these buildings I put together. So I even got a little restaurant going on here, right? Got the little bar there, and I got booths. I got a jukebox. Come on, that's pretty classy. I wouldn't mind living here. So I got my defensive turrets right there. I got. I need to spread out some of these beds because they're a little close. I wouldn't want to sleep that close to people. What else? I got two giant generators, and here's this other building that I just put in for some people. So that was a lot of work there. It took me a long time to figure out how to do a good job with buildings. So I did that, and got a little humor for you. My cats. All right. We have these really nice cat beds for my cats, but this is my cat this morning. That is a box that the food was in, and the cat, instead of sleeping in these really nice cat beds that we got by the window, which if I were a cat, I would totally be all about sleeping in a nice bed. My wife even found this. It's like a banana, and the cat can go inside of there. It's awesome. If I were a cat, I'd totally be on that, right? But the cat would rather sleep in the food box. Don't understand that. The cat's not very bright. All right, so physics. Let's talk about what you have to do this week, and then let's jump into today's stuff. So this week, you are graphing data today. If you haven't done that already, I'm going to go through how to do it in Excel and Google Sheets. Tomorrow, you're going to write your claim and your evidence, claim and reasoning, that should say. Claim and reasoning. No, evidence and reasoning. No, claim and reasoning. Wow, I totally botched that. Claim and reasoning, and then Wednesday, Thursday, you're going to be working on your lab report, and I will help you do that. When you get into chemistry and when you get into some of your college classes, you are going to have to write some lab reports. So we'll break it into small chunks, and we'll do it. 3 days is totally realistic. This is not like a full-blown, like crazy, like it's going to be pages and pages and pages of just science nonsense. It's not that bad. Okay, so we'll work on that later this week, and then Friday, again, we'll have our Zoom rocket launch. We'll get back to you tomorrow with the time. So for today, I'm going to show you how to do your graph in both Excel and Google Sheets. So if you haven't done this part yet, let's do it together. So I'm going to open up OneNote and bring this on out. Okay. So here is some sample data. You're going to have your own data in your lab. All right, and let me just do this, and let me bring out, let's do Excel first. All right, so let me bring this over, and here we go. Oops. Okay. And let me see if I can make this a little bit smaller so it's easier to see. All right. So on Excel, let me make this also a little bit bigger so you can see a little better. All right. In Excel, I'm going to start by entering our data. All right. So you were either doing the voltage or you were doing the number of loops. Okay, so for this one, I'm going to do the number of loops. You don't need to enter all 4 columns of data. You only need to enter the average, okay, or one column, because they're all the same. So this is going to be field strength, and the units are G for Gauss. Right, and then I'm going to enter my data 1, 2, 3, 4. And then 10, 20, 30, 40. All right, are we having fun yet or what? Okay, I'm done with my data, so I'm going to make this a little bigger. Okay, if you're doing this in Google Sheets, which we'll do in a minute here, you're going to do the exact same thing when you start. All right, next, I'm going to go up to, well, first of all, I'm going to highlight all my data, including the titles at the top. And then I'm going to go to the Insert menu. And then I am going to go over to Charts up at the top. I'm going to select this box with the ... Did you say yeah, no? You love graphing. Graphing is so much fun. Graphing is a skill that you're going to have to use probably in any job that you do, right? If you are, at a business, you're going to have to do all sorts of reports. If you've ever seen the movie Office Space, TPS reports, you name it, you probably going to have to do a graph at some point. Okay. All right. So charts, and then you're going to insert this one right here. This is a scatter plot, the one with all the dots on it. So I click that. I like how when I started doing graphing, the number of people watching just dropped. Oh boy, I'm sorry. Okay. So it inserts your graph just like this. Now, if you notice our graph is missing a few things, then we're going to go ahead and add those. So up at the top, we're going to change. Well, let's do our axes titles first. So if you go over to the right side of your graph, you'll see the little plus sign. All right, this is the chart elements. If you click that, you can go and click on axis titles, and then we're going to add in our information. Okay, down at the bottom, this is the number of loops. This is our independent variable, number of loops. And then the dependent variable on the side here is the field strength. And the units are G. You don't need units for the number of loops because it's self-explanatory. All right, at the top here, our title is always going to be the y-axis versus the x-axis. So the y-axis is field strength. And then our x-axis is the number of loops. All right. The only other thing that we have to do on our graph is insert a trend line. So if it doesn't show up, you can click on your graph again, and then you're going to go up to the chart elements, and then you're going to go down to trend line, and it will insert a trend line. Done. That's all you need to do. Now, if you want to get fancy, you can do all sorts of crazy things with your graph here. You can click on the title, and let me bring my, oops, where did my menu go? View, here we go. You look like a trend line. What kind of insult is that? You look like a trend line. All right, so if you want to make your graph look really snazzy, we could bold our title here. We could make it bigger. Look at that. We could make it a different color. We could make it purple. Right? And same thing on the titles on the side. If you click on them, you can go up to the top and change them around. So I'm going to make that a little bit bigger. I make that a little bit bigger. It's my insult. Okay. So any of the titles, you just click on them. You can change the font. You can change the color. If you click on the trend line here, you can do all sorts of things with this. You can do different types of trend lines. Really, the only one that you're going to need in chemistry and physics is just the regular linear. But if you want to do different ones, you could. You can change the trend line color. Like, let's say you didn't like the color blue and you wanted to make it red. You can make it red. You want to make it thicker, you can. Sub to my YouTube channel. I'm going to start doing vlogs again. I should. So you can do all sorts of crazy things with your trend line here. Okay. Pretty much anything in Excel. The cool thing is if you just click on it, even I think the axes lines here, if you just click on it, it'll bring it up on the side here and you can change it. It makes it very easy to customize your graphs. You can make the background different colors. You can do whatever you want. Okay. Now, when you're going to insert this into your lab, just remember that I have to be able to read it. So don't get too carried away with your colors and make it like black and like dark purple or something, or brown where I can't read it because all the colors kind of blend together. So keep that in mind. All right. Once you're done with your graph and you're happy with the way it looks, at a minimum, I did, and we'll come back to that when I'm all done. All right. Once you have your graph all done, at a minimum, you need to have the title in here up at the top. You need to have a title for your y-axis. You need to have a title for your x-axis, and you need to have a trend line in here. Once you have all of those components inserted, you're going to copy your graph and then go back to OneNote. And then you're just going to paste it in here. So you can do on your keyboard Control V, or you can go up to Home, and then where is the paste? Insert. I guess it's not in the top. If you right click in here, you'll see the paste option and it'll paste your graph in. Okay. Control V is the shortcut for that. And then on here, you can resize it. It doesn't have to be crazy busy. crazy big, but you can resize it. But once it's pasted in, you can't make any changes to it. So I would recommend maybe saving your Excel file. So if you do realize, oh, I made a mistake and I need to go back in and redo it, you can go back to the file rather than having to recreate the graph. Okay, so that is Excel. Let me show you how to do the exact same thing in Google Sheets next. Because a lot of you I know don't like to use Excel, which is fine, and you've grown up with Google Sheets. So let's take a minute and let's do a Google Sheets. Okay, so here's Google Sheets. Looks very similar to Excel. The other thing I noticed too is the logos, like the Excel logo is green and the Google Sheets logo is green. Like green apparently is the logo, the color for spreadsheets. All right, and let me bring up OneNote. Okay, same thing. First step is going to be entering our data. So the number of loops and then the field strength. So Google Sheets will save your document automatically for you. If you click up at the top here, you can change the name of this. So I'll call this like mag CER graph, something like that. Okay, so I'm going to enter my data, 1, 2, 3, 4, and then my field strength, 10, 20, 30, 40. When you go to do your graph, use your data, don't use mine, because my data is wrong on purpose. That's how I know who's cheating. Okay, so I'm done entering my data. I'm going to go ahead and maximize this window here. And then just like with Excel, I'm going to highlight my data, including the titles up at the top. And then I'm going to go up to the top to the Insert menu. This is where Google Sheets and Excel are a little different. When you go to insert your chart, you're going to go down to the Insert menu, and then you have to go down to Chart. Okay, so if you notice, it defaults to a line chart. You want to click on the type and go over to Scatter Chart. Okay, so there's my graph. And Google Sheets does some of the work for you. If you notice, it automatically put in titles. So it's picking the titles up in the very top row here. It also defaulted to this title. So it's doing a lot of the work for us. Fewer steps. Okay. So if you wanted to center that, you can. It's kind of like Excel where you just click on things and you can change them around. So, you know, if you wanted this to be bold, if you wanted it to be a different font or colors or whatever, you can do all sorts of crazy things in here. Again, don't try to do too much, make it too busy, because it's got to be kind of easy to read. So, you know, we'll just change a few things here and then call it a day. Okay. To insert your trend line, you are going to go, let's see, it is under, okay, so if you click on the dots on the graph itself, there's an option down here for trend line, and it will insert it like that. All right, so a little bit harder to find, I think, than in Excel, but it does the same thing. You can change the color, do whatever you want, but again, try to make it easy to read. You don't want to make your graph look like a giant mess. Okay, once you have your graph done, I believe you can just copy. Nope, you can't copy it. Oh, you can. So you have to go up to the menu to copy it, and I believe you can just paste it in. Let's see. Yep, same thing. So you can use the shortcut on the keyboard, Control V, or you can right click in here and then go to paste, and it'll bring your graph in. Okay, and then you can resize it, do whatever you want. You just need to paste the graph in. So in your lab report, under the evidence portion where it says graphical and mathematical models, you just need to paste in your graph. You don't have to do anything else there. Tomorrow, when you get into the claim and reasoning part, you're going to just reference this graph. Okay, so you'll talk about your graph later in the lab, but there's nothing else that you have to put in this section here. Okay. Any questions on the graphing? I know I went a little fast, but this is something that we've done before, and I also posted a video on it this morning. Mr. Knott posted a video. It was how to do the graph in Google Sheets, but it was using the last lab data, so if you follow the same process, you'll get there, or just we did it together. This gives you anxiety, graphing or physics. Live streaming gives me anxiety. So yeah, that's pretty much all you had to do for today is make a graph. Should have taken you like 5 minutes. Um, so tomorrow you're gonna do the claim and reasoning, and that's it. Later this week we'll do the lab report and I'll chunk it. But if you want to work ahead, if you go to my website, so Zorn Science. So if you go on my website and you go to classes, physics, and then I believe I posted it under statics. Yep. So physics, physics, and then statics, and then down at the bottom is the electromagnet lab. And this is everything all in one place. So it's got the demo that I did. Okay. Can you link your YouTube channel in the chat? So it's got the video that I did, the demo. It's got how to use the PhET simulation, how to write the methodology, how to do the data table, how to do what we just did in Excel. And then down here is the claim and reasoning part. So if you're done with the graph and you want to get a head start on the next section, tomorrow we're doing the claim and reasoning. Just watch the video. And then, I don't know if you noticed this, but it says right here, this is fake data. Don't use it in your lab or I'll know you copied. So if you want to get a head start on that, you can. I do not have videos for the lab report, but I am going to get those done probably later today or tomorrow. So if you want to work ahead, you can. But if you could just focus on getting the evidence in, the graph, and then the claim and reasoning, if you want to do that for tomorrow, you can. But that's pretty much it. So, Denzel, you mentioned the, yes, I know. It's kind of sad to find out that we're not going back this year. That's very disappointing. I feel really bad for the seniors who this is their last year and this is how they have to go out. I know that the school has rescheduled prom for June, I believe. It's either June or July. So at least maybe that'll happen. Hopefully that happens. The state of Illinois has not extended the stay-at-home order, the quarantine order. So as of right now, that's supposed to be lifted at the end of this month, but I have a feeling that that's going to get extended just based on everything that's been happening. If you go, let's see if it pops up on the website. Yeah. So if you go to the Weather Channel, I don't know why the Weather Channel is doing this, but if you search, so like Joliet, Illinois, if you search for Joliet, Illinois, which I just searched for Joliet, for some reason it keeps going to Plainfield. If you go on here and you scroll down, they have the number of confirmed cases and they have the deaths in that as well. But this is a good visualization of what they were talking about with the curve. Okay, you know how they're talking about flattening the curve. And if you look on here, especially if you look at like 411, 412, if you notice the difference between this, so this is a pretty big growth right here. I believe these are the number of new cases each day. So this is what's happening each day. So like yesterday was the 19th. They're saying like there were 1,643 new cases and 101 people passed away. Today they don't have new data yet. That's why it shows the same. But if you look on here, the number of cases, so like from the 18th to the 19th, it goes from 1603 to 1643. Okay, so that's only a difference of 40 from the day before. And then if you go between these two cases, so 1566 and then 1603, you know, it's starting to slow down. I guess it shouldn't give you anxiety because it's starting to slow down. It looks like it. Okay, so if you go between these, the amount that's happened, the amount that it's growing is going down. So like here, so like from the 14th to the 15th, it was almost 100 new cases that day. So it's starting to cut down. All right, so the point I'm trying to make with this is it looks like it's starting to slow down, so it looks like there's going to be an end in sight, okay? So I know it's still a scary time and there's a lot going on, but if you want to look at facts, like the news is really blowing things up, and it gives me anxiety looking at the news. But if you have the Weather Channel app on your phone, you can pull this up as well. And just look at this graph. This is actual data that they're looking at. So you can see that things are starting to slow down a little bit. So there might be an end to this soon, I hope, because I'm losing my mind. There's only so much Fallout you can play in one day. My kids are going crazy. The weather's starting to get nice. I want to go out and do things. I don't want to be stuck in my house with nothing to do. Don't get me wrong. You can Uber Watts me some tacos. Do you need tacos? Are you like out of food and you need tacos? I just had tacos last night. I made them myself. They were not as good as authentic Mexican tacos. The place right behind the school makes the best tacos. I definitely miss that. Actually, isn't there a sip day this week? On sip days, every sip day, like all of the physics teachers, we would walk across the street to the taco place and get tacos and then come back and eat them. So I've missed out on several taco days, taco Thursdays. Yeah, I need a good recipe for tacos. My kids hate tacos. I don't know what's wrong with them. Yeah, I don't. You know what? I have not Uber Eats or any of that stuff, any of the food since this all happened. Like we used to do Uber Eats before, every now and then when we're feeling lazy, but we haven't used it at all this whole time. We haven't had any food from any restaurants, which I kind of feel bad because restaurants need money, but we're a little paranoid about everything. My wife, she's got that medical background. She's a little crazy with some stuff. Like we're having to sanitize the mail when it comes in. I have to go out there with like a mask and gloves on to pick stuff up, which I think is that might be overkill. So yeah, we haven't had any of the Uber Eats or what's the other one? Grubhub. Oh, my kids are yelling. Somebody's in trouble. That's not good. Hold on. Let me message my wife and make sure everybody's okay. All right. So anyway, if anybody wants to babysit, that would be fantastic. I'll just send my kids over to your house. So that's a no on the tacos are expensive. Where would you get tacos from? Where'd you get tacos from? Don't say Taco Bell because those are not tacos. Where should I get you tacos from? Burrito Loco? How much you paying? My kids are pretty bad. Hold on, I'm gonna get this out. I'm gonna do this with you. Shopping. Where's food? You do not want to watch my kids. They are bad. They have been like going absolutely crazy. Let's see here. Well, I have to go to like Joliet, right? Let's see. Is there a way to just find tacos from an address? Leave at door. Just straight up chicken on your tacos. That's all you would get? Oh man. This is making me really want to get tacos. So much good food on here. Why are you doing this to me? I can't. I gotta be strong. Gotta be strong. No. Oh my god. You do not want to babysit my kids. It's bad right now. My kids need chicken? When all the grocery stores started having their whole thing where they were like, out on everything, um, I managed to score a big load of chicken, and we ate chicken. Well, I'm a vegetarian, so see, I told you, you do not want to watch my kids. Oh my god, what is going on? All right. Anyway, so yep, that's my daughter crying. I don't know what the heck's going on out there. Okay, so let's just move on and pretend like there aren't kids screaming in the background. um, I don't know. I kind of feel bad for my wife that she has to deal with them right now. So Plainfield, the district that my kids are in, um, which you guys complain about your district and how bad it is, you say, but you have no idea. Like they do not. It's not a one-to-one district. So all the kids don't have laptops. They're kind of relying on the computers that the kids have at home, and a lot of the teachers are just kind of like it's not as organized. Which I mean, it's not their fault. They're just working with what they have. Whereas in our district, everybody has computers, and we kind of had a e-learning plan in place. So their school only has class 4 days a week. They don't have like the teachers have a plan day on Monday, so the kids only have to do e-learning on Tuesday through Friday, but they get more work per like a lot more work per day than you guys do. At least in our district, they've kind of all the teachers have kind of gotten on the same page where nobody should be really assigning you like tons and tons of homework. I think our district has done a really good job of communicating that to the teachers. So in my kids' district, they're getting a ton of homework to do every day, and it's very frustrating. And my wife's trying to handle all that while I'm trying to do my job. So anyway, so I'm going to go ahead and switch gears to chemistry. I don't know if there's anybody here for chemistry, but I do have some practice problems that I want to go through for chemistry. So you're welcome to stick around if you want and learn some chemistry, or still got to do work. I'm stressing over here. All right, well, I'll see if I can send you some tacos. Steak tacos, right? That's what you said? I used to eat steak tacos when I was not a vegetarian. I kind of miss them a little bit. Cilantro and onions or American style? This is important. You said yes. Which one? Cilantro and onions or American style? I prefer cilantro and onions even when I do my steak and OFC. I don't know what that means. The first one, onions and cilantro. That's the way to do it. I love onions and cilantro. Even with veggies, onions and cilantro is the way to go. Okay, so I'm going to get rolling on chemistry. If anybody is here from chemistry, we're going to go through some practice problems in a few minutes over the content that you got today. But for the question of the day, it is what is your favorite board game? That's the question of the day. Well, I got to finish live streaming. I can't order you tacos in the middle of my live stream. Do 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 do. Okay, so if anybody's is anybody here for chemistry? If not, it's okay. I'm still going to go through the practice problems. I'm just curious if there's anybody watching so I know to go a little bit slower. All right, so favorite board game is the question of the day, and if you've been watching this whole time, you already know my answer. My answer is the game of Risk. Risk is an awesome game. There is a little bit of skill involved, but there's also a lot of random chance because, you know, so you're just rolling dice and you're going against somebody else. It's kind of like the game of War. If you've ever played that with cards, whoever has the bigger number wins. So that's kind of like what happens with Risk. You just roll dice and you want to have bigger numbers than the person you're going against. And there's some strategy involved with how you group everybody on the board and with what countries you place your pieces in. But if you're really lucky, it can be fun. You could totally turn the tides on somebody like that. Okay. Over the weekend, the weather was really nice, and hopefully you got a chance to go outside and enjoy the warm weather. I power washed my entire deck or patio. We don't have a deck. We have a concrete patio, and I've said I live in the woods, and a lot of the gunk from trees will get on the patio and it'll turn green. So last summer I bought a power washer, and I power washed our entire patio over the weekend, trying to score some brownie points with my wife. Well, see, here's the thing, Denzel. A lot of people will go back later and watch these on YouTube. I know there's a lot of people that are awake at night and sleep during the day, so some people are going back and watching these later. So I'm still going to go through everything, even though there's only 2 people here. Sorry. Um, so anyway, so I power washed my patio over the weekend and tried to earn some brownie points with my wife. I've been playing Fallout a lot. Fallout is a fantastic game for those of you that haven't played it before. Let me show you what I'm working on. So in Fallout, you build little settlements, and it's kind of like Minecraft, but cooler. So I've got a little garden over there. I've got all these buildings you see there, standing buildings. You know, I put those together. So I got a little restaurant here. I got booths. I got a jukebox, right? Look, there's even lights on the wall, so I don't have to work in the dark. I got my beacon there and my defensive turrets. This is my little sleeping quarters for the people that live there. And I got two large generators. And this is another building that I should probably move some of the people into that building because nobody wants to sleep next to like 8 other people, especially if somebody snores, right? So that's what I've been working on at Fallout. Look at that, you even got street lights out here. Okay, this is probably better than my neighborhood. Did you grade those things? I did. Not yet. I'm going to do all my grading after I'm done live streaming today. I got some chemistry stuff to grade them too. I'll let you know. Okay. Um, this morning when I fed my cats, I noticed that my cat, my bigger cat, his name is Kitten, he decided to chill out in this box that the food came in, which I don't understand because we bought these nice cat beds and we like piled on a bunch of blankets to make it really comfortable for him. My wife even found this really cool cat bed where it's like shaped like a banana and the cat can go inside of there. So rather than sleeping in there, the cat decides to sleep in this box that we were going to throw away that had the cat food in it. Um, I don't know. Cats aren't really smart. But I don't know. Being a cat would not be a bad thing right now. I would be curled up on one of those beds, just not doing anything, just kind of chilling out and taking in the rays. See this back here? You see that patio? Boom! It's like bright white because I power washed that thing. Spotless. All right, so chemistry. Here's what we're doing this week. So there are only 2 lessons this week, and then there's a quiz on Friday, like a quiz over everything on Friday. So today you were supposed to have worked through potential energy diagrams. There was a screencast to watch, and then there was a Google quiz. And then Wednesday, Thursday, you're going to do the same thing with heat of formation. Both of these topics are not too difficult. Heat of formation, there's some math involved, but it's really easy. Okay, as long as you're okay working with negative numbers and you know that double negatives are a positive, it's not too bad. Okay, so same thing. There's a Google quiz. There's only one problem for the one on Wednesday and Thursday. There is also optional practice for both the potential energy diagrams and the heat of formation on OneNote. So if you want to jump into OneNote, you can pull those up and do those. I'm going to work through some of that today for potential energy diagrams. I'll see you later, Denzel. And then Friday, there is a quiz. The quiz on Friday is going to be a Mastery Manager where you're going to have to write on your computer. And then next week, as I mentioned in my email, we do have our exam over the thermochemistry unit. So I did post last week the study guide for this unit. If you want to go in and start working on those problems, that would be great because you get a head start on everything. All right. Next week, at the beginning of the week, we're going to do a live review session. I'm going to do it on Zoom instead of on YouTube so we can get some back and forth. I'm also thinking about possibly doing Kahoot live, so you'll be able to play on your phone and it'll pop up on the screen, kind of like we did in class. So that'll be kind of exciting. So for today, what I'm going to do is I'm going to work through some of the potential energy diagram problems. These are optional practice. If you want to do them with me, you can find them in OneNote under homework, and it should be potential energy diagrams. If you don't see it there, just remember to sync your OneNote and it'll pop up. But I'd like to spend at least, probably 15 minutes going through some of these. And then tomorrow, whatever we don't finish, we'll go through that then. Okay? So let me get a second. Take a minute here and get situated. Let me pull up the problems. All right. So the first problem says sketch a graph for each type of reaction, label the reactants, products, and activation energy. So the first one is an exothermic reaction. Okay. In an exothermic reaction, you are going to end up with less energy than you started. Less energy than you started. Okay. So exothermic here, think of it like releasing energy. So that means that my reactants are going to be higher than my products. So this is kind of tricky to label because it's so small, but reactants and products. I'll just abbreviate. Okay, so again, exothermic, you're releasing energy, so you're going to start with more energy than you finish with. Okay, and then all you're going to do here is you're going to just draw a hump like that. And then my activation energy, my EA, is going to be the energy it takes for my reaction to occur. So activation energy is always the energy to go from your reactants to the very top of that hill. Okay, that is my activation energy. All right. Down at the bottom it says delta H is positive or negative. Okay, delta H, the equation for delta H is products minus reactants. So if you notice on my graph here, my products is lower than my reactants. So my reactants is a bigger number. So if you're subtracting a larger number, you're going to end up with a negative delta H value. The other way you can remember this is all exothermic reactions are going to have a negative delta H value. Okay? And since this is exothermic, we know that energy is going to be released. Okay. The next one is an endothermic reaction. For endothermic means you're absorbing energy. So my ending energy is going to be higher than my starting energy. So these are going to be my reactants. These are going to be my products. Okay, and then same thing. I need to draw in my hump. It's going to kind of look like that. And then my activation energy will go from the reactants down at the bottom up to there. So that will be EA. Remember, my activation energy is this in my graph. So it's basically the amount of energy it takes to go from the energy I'm starting with to the very top, to my activated complex. Okay. Now, my products is a much bigger number than my reactants. So if I subtract a small number from a really big number, I'm going to still end up with a positive number. Okay, so energy is going to be absorbed. Okay, anytime your delta H is positive, energy is being absorbed. It is endothermic. All right, not too bad. All right, down here on the bottom, it says answer the following questions based on the potential energy diagram shown below. First part, label the reactants, products, and activation energy. Okay, so on our graph, reactants are always going to be at the beginning. So this is going to be reactants. Products are always going to be at the end. Okay. Another way to think of this is like when you're baking cookies, your reactants are like your ingredients, and then your products are the cookies at the end. Okay, it's what you're producing. So reactants come first, ingredients come before the cookies. All right. Next, we're going to label the EA, or activation energy. Activation energy is the energy required to raise, to get up to this top of the hill. The activation energy is right here. So this spot right here at the very top is our activated complex. All right. It didn't ask us to label that, but it's important that you remember the activated complex is at the very top of that hill. All right. Next, it says determine the change in enthalpy, which is your delta H, for this reaction. So delta H is equal to the products minus the reactants. All right, so looking at our graph, our products have a value of 100. The reactants have a value of 50. So products are 100. Reactants are 50. 100 minus 50 is 50 kilojoules. Not too bad, right? Question says, does the graph represent an endothermic or exothermic reaction, and then how do you know? Well, if you look, our products are ending with more energy than we started with. Okay, so in order to have more energy, you would have had to have absorbed energy. If you absorb energy, you know it's going to be endothermic. Another way that you could identify this as being endothermic is that our delta H value, this number right here, is positive. So delta H is positive. All right. Next, down at the bottom, it says determine the activation energy for this reaction. Okay, so remember, activation energy is how much energy it takes to get up that hill. So if you look at our graph here, the activated complex at the very top of that hill is at 250 kilojoules. So we're ending at 250, but we're starting at 50. So we want to find out how much energy it took to go from 50 to 250. So the activated energy, or the energy of activation, is the activated complex minus the reactants. So the activated complex is sitting at 250, and the reactants started at 50. 250 minus 50 is 200 kilojoules. Math isn't too bad for this first section here. It gets a little bit more involved with our lesson on Wednesday. So if you've got this and you feel good, my advice would be to start looking at the stuff for Wednesday because it gets a little more complicated. All right, let's look at another one. We're doing good on time. It's easy when I'm talking to myself and I don't have other people asking me questions. All right, number 3, which I don't mind questions, by the way. All right, number 3 says answer the following questions based on the potential energy diagram shown below. Label the reactants, products, and activation energies, just like what we did before. Okay. Your reactants are always at the beginning. So this first part is going to be reactants. And at the end here, this is going to be our products. Okay. The activation energy is always the energy it takes to go from the reactants to the products. And then I'm just going to label this again anyway. This is our activated complex. My OneNote is catching up. My son is probably on Fortnite right now, sucking up all of our bandwidth. All right. Oh, you know what? Why don't we also do this? Let's label our delta H. Doesn't ask for this, but our delta H, our change in enthalpy, is always the difference between our reactants and our products. Activation energy is the difference between our reactants and our activated complex. Our delta H is the energy between our products and our reactants. All right, next part says determine the change in enthalpy, or delta H, for the reaction. All right, now this graph doesn't start and end on very nice numbers. So let's see. It goes from 40 to 60. So 2, 4, 6, 8. Okay, so there's a difference of 20. So each one of these would be 4. Is that right? 4 times 5 is 20. Yeah, so each one of these lines is 4. So 44, 48, that should be 52. So this is 52 kilojoules. And where is this one at? This is, what, 16? Looks like. Okay, so delta H is equal to products minus reactants. The products, the very end is 16, and the reactants is 52. So 16 minus 52 is going to give us a negative number. It's going to be negative 36 kilojoules. Okay, down at the bottom, next question says, does the graph represent an endothermic or exothermic reaction? And then how do you know? Well, we're starting with more energy than we're ending with. So if you start with more than you ended with, that means you would have had to have given something away. So I know that this is going to be an exothermic reaction. And if you couldn't remember what I just told you with, starting with more than you ended with, if you don't think about it like that and you just want to memorize that a negative delta H value means exothermic, that's fine too. So this is a negative delta H value. All right. Last question for this example says, determine the activation energy for this reaction. So our activation energy, EA, is the activated complex minus the reactants. So that's going to be 80 minus 52. And the 80 is coming from right here, because if you look up at the very top, our activated complex is sitting at 80. So 80 minus 52 is going to give us 28 kilojoules. Okay, because our reactants, again, we're starting at 52, so just find the difference between them. All right, let's go ahead and finish this up. All right, this last one says, given the following, PE, potential energy of the reactants, it gives us the delta H value, and it gives us the EA. This is a little more complicated. So we know that our reactants are at 110. Let's see, all these numbers kind of go by tens. So I'm just doing some quick math here. Okay, I know that my potential energy is at 110. The difference between our values is 100, and my delta H value is negative 100. So that means our products have to be 10. So I need my graph to go from 10 to 110. So let me start to draw these in here. 10, 20, 30, 40, 50, 60, 70, 90, 100, 10, 20, 30. All right, so this will be 10, 20, oops, 10, 20, 30, 40, 50, 60, 70, 80, 90, 110, and then that'll be 130. Okay. Not spaced out perfectly, but close enough. All right, so I'm going to go ahead and start by labeling this as my reactants. And I know that because my delta H value is negative, that means that my products are going to be lower, and we already did the math between those. So there's a difference of 100 between our reactants and our products. So 110 minus 100 gives us a value of 10. So I know that I'm going to end here. And I'm going to draw my hump in. Oops. They actually gave us a number. So we know that the activation energy is 20 kilojoules. So that means from my reactants, I'm going to gain 20 kilojoules. So that'll be 130. So I actually drew my axis exactly correct without even realizing it. So we're going to jump up to 130 and then come down to, come down to here. Let's try that again. Close enough. Okay, so we hit 130, so that's 110 plus 20, that's 130. So this is our products. All right, and then this up here would be our EA. Sorry, that's really small. Okay, is this endothermic or exothermic? We know that we're starting with more energy than we're ending with, so this is going to be exothermic. Part B says, what is the potential energy of the products? Well, I already labeled this on the graph, but if I didn't know this, delta H is equal to products minus reactants. We know the delta H is negative 100, and we know the reactants, but we don't know the products. So you kind of work backwards here. So what minus 110 gives you a value of negative 100? I could add 110 to both sides. So if I do that, I get P is equal to 10 kilojoules. All right. Determine the value of the activated complex. This is kind of weird because they have you do all of this in the graph, but then they ask you the same questions. I didn't write this question. All right. So we're trying to find the activated complex. We know it's 130, but let's try to prove this mathematically. Oh, I should have read the directions first because it actually says down here for D, it says sketch what it would look like. I just went ahead and sketched it right off the bat. That's my bad. Maybe this was a good question. All right, so determine the value of the activated complex. The activated complex, whoops, the activated complex is equal to the potential energy, or the reactants plus the activation energy. So the reactants are 110, and the activation energy is 20, so the activated complex is at 130 kilojoules. And I already did the graph. So there you go. So managed to get through all of these. So tomorrow, you have an extra day to work on the same lesson. So if you've already finished everything for today, what I would recommend doing is, if you feel comfortable with it, go ahead and move on to the next section, which is the heat of formation. The heat of formation is the next section. I've already posted everything for that day, so you can go ahead and start on that now if you'd like. If you need help, make sure you hit me up on my website. There's a place where you can book a one-on-one Zoom appointment, and I'm happy to work through those problems with you. And then Friday, we have a quiz. So the quiz is going to be a Mastery Manager. You have the codes already for that, so if you feel confident and you want to jump in and take the quiz now, you can. Otherwise, you have until Friday to knock that out. All right, so unless you have any other questions, I'm going to go ahead and wrap up my stream. I hear my kids yelling right now. This is not going well. I should probably keep streaming so I don't have to come out and deal with my kids. But I'm going to just go anyway. Got to be strong, right? All right. It was good to talk to an empty room of people today for chemistry, but sometimes it is what it is.